So it is day 5 in geometry, and I'm going to write the date on here. Let's see. It is Monday, what is it, August 11th. Okay, and this worksheet that I gave you is, you're just finding x with angles. I gave you a couple little hints. I said set up equations to solve for x. Basically, you want to decide, are the angles equal to each other or do they add up to 180 degrees? Now, number 5 on this worksheet is a challenge because I have not taught you this yet. If any of you tried it, when we get there, you'll have to tell me about it and see if anybody got it right. But if you were completely lost on number 5, don't worry. I haven't taught you how to do this yet. So, let's go ahead and start with number 1. Before we work it out and decide the best way to do that, I want you guys to tell me, just shout out some of the answers you got for x. Did anybody solve number 1 and get an answer for x? Did you get an answer? What did you get? 58. Did anybody get something different than 58? I don't know the answer off the top of my head. That could be right, that could be wrong. Are we quiet because we didn't do it or because we feel not confident about our answers?
I'm second guessing my answer.
That's okay. Tell it to me, whether it's right or wrong.
The first one I got was 4.
Okay, 4. So 58, 4. Did anybody get a different number than 58 or 4? It's okay if it's totally off. I like it when you give me wrong answers because it's just an opportunity for us to learn.
I got 58 and 4.
Okay, 58 and 4. So it sounds like those are 2 popular numbers we got. So, let's see. I gave you the hint that we could either solve for x by saying the angles are equal or by saying they add up to 180 degrees. So, something that will make this a little bit easier that I like to do with angles is we can pay attention to these markings, the arcs. Remember, if 2 angles have the same number of arcs, that tells us they are the same size. Do these 2 angles have the same number of arcs? No, they don't. So are these going to be equal to each other? No, they are not equal to each other. Would they add up to 180? Yes. Now here's why. This extra line here is just to throw you off. That was mean. Sorry guys. That's just to throw you off. We don't even need that. Notice that this angle and that angle form a straight line, which is 180 degrees. So if it helps you to visualize that, mark on your paper what's going on here. This is a straight line. Okay. Here is one angle. And here is the other angle. Notice how this one has 2 arcs versus 1. So they're not equal, but they form a straight line. So they're going to add up to 180 degrees. So if this is angle A and this is angle B, I'm just really breaking it down. You don't have to do this part. I should reasonably be able to say, right, that A plus B equals 180. Do we agree or disagree with that? Can I say that these 2 angles add up to 180? Yes or no? That's all I'm looking for. Are we sleepy this morning, guys? That's okay. No, you're fine. You're fine. Or how about this? Give me a thumbs up if you agree. You agree? This makes 180? Yes. Okay, I love it. Perfect. So, what equation would I write instead of a plus b? What could I do?
X plus 5
Mm-hmm. X plus 5
plus 2x plus 1
plus 2x plus 1. Perfect, equals 180. We just replaced a with x plus 5 and b with 2x plus 1. All right, so now we have an equation, and this is correct. This is perfect. Now that we do have an equation set up, what should I do next? Combine like terms. I've got x, what else? And 2x. Yes, which makes 3x. Cross that off. Can I combine anything else? Yes, plus 6. The 5 and 1 makes 6. So let's combine 5 and 1 plus 6 equals 180. Perfect. Okay, where do we go from here?
Subtract 6.
Yes, 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 yes. Subtract 6. Okay. Bring down 3x equals, what is that, 174? Good.
And then divide.
Yes, divide by 3. And you will get x equals, sounds like 58 is going to work. I'm going to type it in just to be certain. 170, oh, it's not on. 174. 174. Okay, this calculator's broken. Let me get a different one. 174 divided by 3. Yep, 58. Okay, so x equals 58. Perfect. So you guys were right. To get x equals 4, did you set them equal to each other? Got it. Okay, so yeah, that would give us a different answer. It's tricky. We just have to look at those markings and decide what makes sense. I think that's the hardest part, is deciding how to set it up. Okay, so that was number 1. Do we have any questions about number 1? Or we feel good about that? Okay, we'll go ahead and move to number 2. How are these angles related? They are equal. How do you know they're equal? They both have one arc. Now, this is another one to kind of throw you off. What kind of lines are these? Straight lines, but how are these two lines related? There's a special word. Starts with a P. Parallel, yes. These lines here are parallel. And this line is the transversal. Okay, so these two angles are equal because they are corresponding. This line here is just extra to make you confused for no good reason. Okay, so if these are equal to each other, what equation should I write? Yes, x minus 4 equals 91. And how would we solve it? Just one step. Good, add 4 to both sides. And those 4's cancel, so we get x equals 95. Okay. Anybody get something different than 95? Or y'all get that? Okay. Now, don't be afraid to stop me if you're not fully understanding. Or are we? Everybody feel good about this? Okay. Okay, cool. We ready for 3? Okay. So, number 3, how are these angles related? They are equal again. So, we're going to set this up really similar to number 2. If this is A and B, and I know A is equal to B, what equation do I write?
3x plus 2 equals 5.
Good. 3x plus 2 equals 5x. Okay. So now we have variables on both sides of our equation, which can be a little tricky. Yes. Subtract 3x. Now, do any of you know why we need to subtract 3x instead of what some people might think? Maybe they would think divide by 3. Why can I not divide by 3 here? Anybody know? It would become a fraction, and that would be really kind of tricky to work with. And if I divided by 3, not only would I get a bunch of fractions, but it wouldn't bring all my x's to one side. I would still have variables on both sides. It would just get rid of the 3. So it wouldn't be helpful. So subtracting 3x is definitely the move here. So we'll bring everything down. I've got 2 equals 5x minus 3x. What's that leave us with? 2x. Good. Now we can divide by 2. Good. And we get x equals 1. Perfect. And that makes sense for our problem. How do we check our answer if I wanted to make sure this was right? Is there a way to check it? You could put it in the calculator, absolutely. You could also stick my x value right in here. And, well, 3 times 1 is 3, plus 2 is 5. 5 times 1 is 5, and 5 equals 5, so we know that's right. Awesome. Okay, any questions on number 3? Any questions at all? Okay, let's go to number 4 then. For number 4, we'll call the angle 2x minus 4 angle A, and we'll call 6x minus 12 angle B. Is A equal to B, or do A plus B equal 180? Equal. Do any of you remember what kind of angles these are when they're right across from each other? Sorry guys, I'm asking you a lot of questions for a Monday morning. Very, very, very close. It's one of those words though that we learned last week. Starts with a V. Yes, vertical. Good. Vertical angles. Vertical angles are equal. So, if A is equal to B, what equation would I write?
2x minus 4 equals 6x minus 12.
Perfect. 2x minus 4 equals 6x minus 12. Okay, now again, I've got variables on both sides of the equal sign. What should I do? Combine my like terms. I've got x's, I've got non-x's. Would it make more sense to subtract 2x or to subtract 6x? 2x. We like to keep our variable positive if possible. So we'll subtract 2x from both sides.
You got negative 4 equals 4x minus 12.
Perfect. We're left with negative 4 equals 4x minus 12. And what can I do from here?
Add 12.
Yes, add 12. That gets rid of my 12s. Negative 4 plus 12. What's that? 8. Good. 8 equals 4x. Divide by 4. Yes, perfect, perfect. X equals 2 for number 4. Good, good, good. Let me move that up. X equals 2. And here's that work if any of you need it. And we're going through these kind of quickly. I'll pause for just a moment. I see a few of us writing. All right, so we're going to move on to the challenge question number 5. I have written here 22 and 50 because those are the 2 answers I got from you guys. And I'm going to grab a separate piece of paper here actually because I don't have a whole lot of room left to write on this. So for number 5, I would actually like all of you to take out a piece of paper because we're going to take a quick note about number 5. So I'm going to title my page and we're going to come right back to that. Geometry Unit 1. And today is day 5, so these are going to be our day 5 notes. I need to get a new black marker. That one is running out. Wait. And again, today is Monday, August 11th. Okay, and for number 5, what we're going to call this type of angle relationship, we're going to call these angles around a point. So that's what I'm going to title my notes. Angles around a point. And then I'm going to kind of redraw number 5 in my notes just to give an example. So to draw number 5, what I'm going to do is start with a point. And we're just going to draw some lines coming out, 3 lines. Let me get a ruler. And it's okay if it doesn't match the picture perfectly. A line here, or a ray here, and a ray coming out here, and one more here. So we've got 3 rays coming off of a single point. Now you might look at this and say it looks like 2 angles until we add that 3rd angle. So we will call the largest angle, we'll start by giving it an arc going all the way around. We'll call this angle A. And angle A is 250 degrees. The next one we'll call angle B, and we'll give it 2 arcs because it's not the same as A. And that's going to be 4x degrees. And then angle C is what we'll call the third one. We'll give it 3 arcs. 1, 2, 3, because it's also different than the first two. Angle C is just going to be X degrees. Now, do any of you know how many degrees these 3 angles will add up to?
250.
Almost.
No, 60.
360. Oh. Now, where did I get that number? So, I'm going to show you where I got that number. If you have a straight line, remember, if I have a straight line like this, it means that I have an angle that starts here, opens up all the way, and it is 180 degrees. Now, if I were to rotate all the way around again, that's another 180 degrees. So total 180 plus 180, 0, 6, 360. So there are 360 degrees in one full rotation. Because if we notice, if we start from angle A and we go all the way around, it creates a circle. All 3 angles create a circle. That wasn't a very pretty circle, but it is. So a circle is 360 degrees. So we're going to make that note. Angles around a point add up to 360 degrees. And if it helps to draw this little picture, we could do that too. So to write my equation, I know that A plus B plus C equals 360. So I'm going to start with A, B, and C, and we'll replace it with the values they give us. A, B, C equals 360. And then A was 250. B was 4x, and C was x. So here is our equation. All right, so we have our equation all set up. What should I do next? Yes, let's add the x's. 4x plus x, that gives us 5x. I'll bring down the rest. So 250 plus 5x equals 360. What do I do next?
Subtract 250.
Yes, subtract 250 from both sides. 5x equals 110. Divide by 5. X equals 22. And that is one of the answers we got. So. You were super, super close. This one was tricky because I've never taught you. That's all right. So number 5, x equals 22. So to get 50, did you add them Or did you do like x plus 4x equals 250?
Yep.
Ah. Can you see visually why that doesn't work?
Well, yeah, now.
Yeah, yes, now we can see that this big angle is definitely not the same size as these two added
So,
together.
I kind of went ahead a little bit in YouTube videos, like,
Uh-huh.
started doing this and then I'm like, oh, okay, now we know what I'm doing. I thought I knew what I was doing.
Oh, that's funny. Well, hey, now we know. Okay, so angles around a point. Those add up to 360. All right, so it's really just the three of us, so I'm going to ask you guys pretty candidly, how do we feel in general, confidence-wise, solving for x with angles? Do we feel pretty good about it? Do we feel like we would like more practice before moving on? I was planning on practicing with you guys today, but y'all seem to be catching on pretty well. I don't want to assume that we're ready and just jump.
I feel good.
You feel good? Okay, give me like thumbs up, thumbs in the middle, thumbs down. Okay, cool. Cool. And we'll come back to this when we start doing review. But man, you guys want to learn some of the new topics today? Something different? No? Well, too bad. You're gonna learn. You're gonna learn today. I'm gonna write, this is page 1 of our notes. You can hold on to that. That'll be helpful when we do review later. Yeah, hold on to that do now. You have, you get credit because I saw you do it.
I'm gonna make sure I'm turning all my stuff.
Yes. The only thing you really turn in is exit tickets in here, unless I specifically say, hey, I need you to turn this worksheet in. Okay, so we will come back and do more angle practice, but for now, let's just introduce the next thing. And I'm going to title my page again. So, geometry again. Unit 1. And this is day 5, notes. Continued. And this is page 2 of our notes. So, this morning we looked at the Google Classroom post where we talked about the topics, and we said we were going to be looking at the distance formula and the midpoint formula. So, we're going to start with the distance formula. So we're going to title this page of our notes, Finding the Distance Between Points. And when I say points, I actually am referring to points on a graph. So finding the distance between points. Now, I want to just reintroduce this concept. This is a point, this is a coordinate, and there's always going to be 2 values. There's going to be a number that is an x value, and there's going to be a number that is a y value, and it's always in this order. I'm going to call this a point or a coordinate. And at each of your tables, and tell me if you don't have one of these, I will happily give you one. Each of you should have at least one pad of sticky notes with a coordinate plane or like a graph on it. If you don't have one of those at your table, just raise your hand and I'll bring you one. So these are so cool because now we don't have to draw a graph. I'm going to just pull one off and put this in my notes right here. And all we have to do is draw an x-axis and a y-axis. So I'm going to line my ruler up against one of the lines here. I'm going to start by giving myself two little arrows to go through. And we're going to go straight up and down and draw a line straight through here. And then I'm going to do the same thing, but going left to right, like this. Okay. Now, once we have drawn our axes, and when I say axes, I'm just talking about the lines themselves. This is what we call the x-axis and the y-axis. First of all, the x-axis is the one that goes left to right. So I'm going to label that x, and I always make my x's red and my y's blue. And you don't have to do that. That's just what I do. And then my y goes up and down. So we'll label that as the y-axis. And then on the x-axis and the y-axis, at each of those little boxes, we're going to draw a little tick mark, just to give us kind of counting points here. So I'm going to do this on both sets of lines here. We could even go a step further and put some numbers, although these are pretty tiny, so if you can't fit it, that's not the end of the world. And we'll start here. Now, you guys, we are in geometry, so that means typically this is the last math class you take, and most of you have probably already learned about the coordinate plane. But I don't like to assume. It's so easy to forget these things, especially if you haven't been in school for a while. So whenever we are numbering our coordinate plane here, I always like to start with the right side here of the x-axis, and these are going to be our positive numbers going to the right, and then this middle point here is basically our 0, and then to the left we have our negatives, so -1, -2, -3, -4, -5, -6. So the x-axis, we have negatives to the left, positives to the right, and our y-axis, positives are up, negatives are down. So I'm just going to label that as well. 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. Okay, so I have a nice little graph here. And we just want to make sure that we understand how to name a coordinate, how to label one. So let's say I have a point or a coordinate right here. What would be my x value for this coordinate? -3, good. So this would be -3 is my x, because it lines up with -3 on the x-axis. What would my y value be? 3, +3. That's where it lines up. Okay? And let's get one more point on here. How about this one? What would be my x value for this point? Three, perfect. And my y value? 6, good. Good, good, good. Okay, so I've got 2 points here. Whenever I have 2 points that are just straight next to each other, like this, for example, and I wanted to know what's the difference or what's the distance between these 2 points, I could just count the spaces, right? And I could say, oh, it's 1, 2, 3, 4 units away from the other one. But these 2 points, my 2 purple ones, are not on the same x value or the same y value. They're kind of diagonal to each other. So here's where we are going to use the distance formula to find the distance between point A and B. I'll call that point A, point B. So I'm going to move that to the side and I'm going to give you the formula. Now this distance formula is something you don't want to lose. We will use this again. So make sure you mark it in some way that you'll be able to find this. Distance formula. So our distance formula is, we're going to start with a square root, a big square root. And under that square root, I am going to start with a parenthesis and I'm going to write x2 minus x1. Close the parenthesis. And outside of these parentheses, we're going to put squared. So x2 minus x1 squared plus another set of parentheses. And this one is going to be y2 minus y1 squared. This is your distance formula. It looks like a lot, but it really isn't, and I'll show you how. It's also a way easier way of solving this. So I'm just going to make sure that I know this is my distance formula. So once you've got that formula written down, we're going to use the formula to find the distance between these 2 points here. So what I want to do first is just write the coordinates out beside each other. Point A is -3, comma, +3. And point B is +3, comma, +6. So I want to find the distance between these 2 points. coordinate, the x comes first and the y comes second. Before using this formula, the first thing I will always tell you to do, and I will always recommend, is to label your coordinates. So, is -3 an x value or a y value? That's x, good, because it comes first. So x, and we'll call this x1. Then the +3, that's the y value. So we'll call that y1. There you go. So then 3 and 6 will be x2, y2. Now you have all the information you need to use the distance formula. So we'll run through this one together. I'll let you try some. Now what I like to do whenever I'm using the distance formula is I like to start by writing the formula and leaving myself a bunch of blanks. So I am going to start again with a great big square root. And then I'm going to write parentheses squared with a minus plus parentheses squared with a minus, just like this. That's the first thing I'm going to do. Okay. So, looking at the formula, what is going to go in this first set of parentheses? Right here. 3 and -3. Good. x2 is 3, and that comes first. Now, here's where it gets tricky, and this is why I always say go ahead and write the minus in and then fill in your numbers. x2 is 3 minus x1. x1 is -3, so it's minus -3. Not just -3, minus -3. Okay. Now, what's going to go in the next two blanks? Yes, y2 is 6, y1 is 3. Okay, so now I've got the square root of 3 minus -3 squared plus 6 minus 3 squared. So, as we go on to the next step, be very careful with a minus negative. Do any of you know what really happens when you do minus a negative? Or is this going to be a new concept? Or it might just be a reminder. It does. It's going to turn into a positive or a plus. If I did 3 minus 3, I'd get 0. But if I do 3 take away minus 3, it's basically the same thing as adding 3. Minus, negative, those two minuses, anytime you see a minus, minus right next to each other, go ahead and cross them out, turn it to a plus. This is 3 plus 3. You can also type that in your calculator if you ever want to be completely certain. I can show you right here. 3 minus -3. You're going to get 6. Same as 3 plus 3. So 3 minus -3 is 6. And we can drop the parentheses and make it squared. Plus, what's next? 3. Yep, 6 minus 3 is 3 squared. And what am I missing? one big thing I forgot to bring down.
Oh, yeah.
Yeah, the thing. The square root. Square root. Okay, so I'm going to cross this off because I'm done with it. I'm going to cross that off because I'm done with it. So now I have the square root of 6 squared plus 3 squared. What should I do next?
We work out the powers.
Yes, work out the powers.
Which would be 6 times 6
Mm-hmm.
equals 36.
Perfect.
And 3 times 3.
Perfect, perfect, perfect. 6 times 6 is 36. 3 times 3 is 9. Yeah, bring down everything else. Now I have the square root of 36 plus 9. Yeah, let's see, what's 36 plus 9? 45. Okay. 45. Still the square root of 45. Now, something I'm not too worried about in this class is having you guys simplify exact square roots and radicals, where you have to like look at all the factors, see what you can break it down into. At this point, what I'll have you do is find the square root of 45 in your calculator. And a quick review on that. First of all, does everybody have one of these yellow calculators? If not, go ahead and grab one, because these are the calculators you'll be using on your quiz, and I want to make sure we're all comfortable with using it. So they're over by the computer cart. I'll pause my video for just a minute and let you guys all get one. Alright, so quick review on how to find square root on your calculator. It's nothing too crazy. You will notice right here on your calculator on the very left side, if you go down, you'll see a button that's x squared, and right above x squared there is a blue check mark, a blue square root. To use any of the blue keys, just hit second first. So I'm going to hit the second button, the blue button, and an arrow should pop up on your screen. When you see that arrow, you're going to click x squared, and looky there, you have a square root. So we just type in 45 and enter, and that's going to be your answer. You do not have to write all of it. Good question. So in geometry and any other class that we're getting lots of decimals, I like for you to keep just at least 2 decimal places. So you could put 6.7, and we'll round up to 1. 6.71. Now, I'm not grading you on rounding. If you wrote 6.70, I'm not going to count it wrong. It's close enough. Although the more, I want to say accurate answer might be the 6.71 if we wanted to round up. Okay. So 2 decimal places. And that would be the distance. So, since we're not giving you like inches or anything like that, what we would put for units is just that. We're going to put units, 6.71 units. And that's about how far away these 2 points are. Now I want to show you something visually on the graph that I think is kind of cool, and we'll see a lot more when we get to Unit 2 when we start talking about triangles. The reason this formula works is we're finding the distance here between these points diagonally. So I'm going to draw a line between A and B, and this is the distance that we just found. So we can label this as 6.71. But something else that we can label is the distance from the x value of A to the x value of B. We're starting at -3 for A, and then we end at +3 for B. And this is 1, 2, 3, 4, 5, 6 units. And look, here's the 6 squared. And from B down, the difference in the y values, that's going to be 3 units. So we've got 6 is one side length, 3 is another side length, and we just found the missing side of a triangle, actually. That's what we did. So if you have a graph, sometimes doing it with a picture can be a little easier than the formula. If you're a more visual person, you can skip the whole first step and just use the side lengths in your formula. 6 squared plus 3 squared. 6 is one side, 3 is another. I don't know. I think that's kind of cool. But, you know, I am a math teacher, so. Okay. All right. So that is our distance formula, and I'm going to give you a couple of examples to try on your own. Or do we want to do one more together? Y'all want to try some on your own? Or do we need one more? Thumbs up if you're ready to try it on your own. Thumb, finger up if you want to do one more. So we're not ready, but we don't want to do more. Do we just want to go home? Yes. Man, you guys. Okay, I'm going to give you one to try on your own. Just one. I'll give you 5 minutes, and after you finish it, we'll go take a break. Okay, we'll take a break. So try this one on your own. Find the distance between these 2 points. I'm going to give you some new numbers. I gotta work it out myself. I don't know it off. I can find it pretty quick though. Let's see. Okay, so try that. I'm gonna try it as well, and yeah, we'll see how we do. Okay, I'm gonna start slowly revealing parts of my work. This was the problem. You got 2 points, and here's what I did. I'll kind of slowly zoom in here. Hello. So I labeled my x's and my y's. Okay, and then I started plugging them into my formula. -12 minus 5 squared plus -30 minus 15 squared. All of that is under the square root. Okay, and in the next step, -12 minus 5, that is -17 squared, plus -30 minus 15, that's -45 squared. So far, does anybody have something different going on? Or is it similar? Same thing? Okay. Then I got 289 plus 2,025 under the square root. Same answer, different answers? Alexis, the second time you did it, did you get something like this?
Yes,
Good, 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 good. Okay, then I added those and I got 2,314 under the square root. And for my answer, I got 48.10 units. Did you guys get it? Yes, no, maybe? All right. Now, if you didn't get this answer, when we go to break, tell me, okay? Stay here. We can talk about it. I want you to never leave this room feeling confused. So, I think we're ready for a break. I think we're pooping out a little. So, I'm going to go ahead and pause this. It is 10:28. I'm going to give you guys about 15 minutes here. So, that would be, I'm really bad at mental math. What would that be like? 43. Okay, so come back at 10:43. All right, guys, so we are back. And I'm just going to take these little notes off of here, stick this one up a little further. Okay, so we just learned about the distance formula. I'm going to flip my page. We're going to do a little bit more with that. So, I'm going to have us, let's see, I'm going to title this page real quick, Geometry, Unit 1. This is going to be page 3 of notes for me. It's day 5 notes continued. Okay. And I'm just going to rewrite the distance formula at the top of my paper, just so that I have it for these next few problems. So, distance formula. And again, that is just going to be the square root of, I like to do my parentheses with minus, squared, pluses, and I like to fill in my blanks. x2 minus x1 squared, and y2 minus y1 squared. I really like using the colors. I think it just helps me stay organized and helps me not to mix my numbers up so much, because I do that. It happens. Okay, so let's run through even more examples. Let's see. Do -4, 5, and 6, -3. Let's do 10, 15, 20, 30. And a third one here. Let's do one with all negatives. Negative 16, negative 2, negative 4, negative 3. Why not? Okay. And before I even start plugging numbers in or deciding where they go, what is the very first thing I'm going to tell you to do to these coordinates? Label them. Label them. That is going to help you more than you think it will. Takes just a couple seconds and it is so worth it. Label your X's and your Y's. X1, Y1, X2, Y2. It really makes all the difference. Okay. So we've got 3 good examples up here. I'm going to run through number 1 more time slowly, just to give one more demonstration of how we use this formula. And then 2 and 3, I'm going to have you guys do those on your own. And I'm going to come around and see how we do with them. But before I start on number 1, I do want to give you a minute to write these down. Okay, looks like we've all got them down. So I'm going to zoom in on number 1. And stop me if I'm going too fast or anything. Stop me if you're not sure why I wrote something. Ask questions. I promise I will never be annoyed with a question. I appreciate questions, and anybody else in this room appreciates it too. Even if you understand it. Just because you ask a question doesn't have to mean that you don't get it. Maybe if you think there's a certain step that might be confusing for others, ask about it. Help other people in the room, guys. So, I have negative 4, 5, and 6, negative 3. I want to find the distance between these points, so I'm going to use my distance formula. So, I'm going to again start by drawing out my formula, but leaving blanks for my values. So I'm going to do this. I'm going to do my x2 minus x1 squared plus y2 minus y1 squared, big old square root. Okay. What will go in my first blank? 6, good. 6 is x2 minus, what's x1? Yes, 6 minus negative 4. And I appreciate you saying that. This is going to turn into plus 4. 6 minus negative 4. Those two minuses beside each other, they do turn into a plus. And if that is a rule that you don't care to memorize, just type it into your calculator. You'll get the right answer. What goes in the next two blanks? y2 is negative 3 minus y1, which is 5. Good. Okay. So we're here so far. And again, if there's anything that I have written that you're like, I don't know why you did that, tell me. Stop me. We can talk about it. what do we do next? Say it again. Yeah, add what's in parentheses here. So I have 6 minus negative 4, or 6 plus 4, and that is, what did you say? 10. Good. 6 plus 4 is 10. And it's not just 10, it's 10 squared. Bring down the squared. Bring down the plus. Negative 3 minus 5. Negative 8. Squared. Okay. So now I have 10 squared plus negative 8 squared, and all of that is under a big old square root. Now, if, again, because this will happen, this negative 8 squared, if you are going to type this in your calculator, do not type it without parentheses, because you will get the wrong answer. There's a couple ways you can get the right answer on a calculator. You can either do negative 8 times negative 8, and you'll get 64, or parenthesis negative 8 parenthesis squared, and you'll get 64. Can I type negative 8 squared with no parentheses? No. You're going to get a negative answer, and this is not correct. The reason your calculator is going to give you the wrong answer here is because it cannot read your mind, and it is doing the order of operations. The way your calculator reads this, negative 8 squared, is saying, okay, well, I have an exponent, so 8 squared is 64. Done with that part. Now I still have a negative left. I'm going to stick the negative on there, and then it gives you the negative 64. So if you want the correct answer, you can do the parentheses, you can do negative 8 times negative 8, or you could just type it without the negative at all, 8 squared, and you'll get 64. Any number squared will always be positive every single time. Does that make sense to everybody? Okay, I hope so. What do I do next? So I did the 8 squared, that's 64, but what else do I do? Yes, 10 squared is 100, so I have 100 plus 64. Still under a square root. And, well, that's going to be the square root of 164. And what is the square root of 164? 8. It is? Hang on, let me see. Because the square root of 64 is 8. What about 164? It's going to be a little bigger. That's okay, that's okay. You should get about 12.81. I'll round that up. 12.81 units. Good. All right, so that was number 1. Number 2 and 3, I want you guys to try on your own. And as you work on these, I'm going to go ahead and, I'm going to make an exit ticket for you guys. So if you feel good about this, great. You'll be able to do your exit ticket and get out of here. If you're feeling really lost and confused, which might be none of you, but if any of you are, Don't be scared to tell me that. I really want to help you guys, and I can't help if I don't know that you need it. So, advocate for yourselves. I'm gonna go ahead and pause this video, let you guys work on 2 and 3. If at any point you have questions, raise your hand, shout my name, anything you can do to get my attention. I want to help you guys. So I'm gonna pause it. Okay, so I'm gonna run through number 2 and 3 a little bit quickly, but stop me if you get something different or if your work is not matching mine. I'm gonna let you do your exit ticket. So, number 2. Would any of you like to tell me how you worked out number 2? What'd you do? I'll start with the square root. 20 minus 10, perfect. And then what was next?
30 minus.
Good, 30 minus 15. Okay, so pretty simple. 20 minus 10 is 10 squared, plus 30 minus 15 is 15 squared, still under the square root. Okay, what's 10 squared? 100. What is 15 squared? 225. Still all under the square root. So 100 plus 225, 325. And the square root of that is, let's see. Yeah, 18.02, or you could round it up to 18.03. I would accept either one. I'm going to write 18.03 just because I'm going to round up, but I would take 0.2 as well. 18.03 units. That is number 2. Okay, you guys all get that? Make sure you're checking your work with me. No matter how confident you feel, you never know if you got one wrong. So, double check. You get that one? Yay! Okay, let's try number 3 now. And then off to the exit ticket. So, I'll do the same thing. I'll start with my big square root, parentheses, minus, parentheses. Okay. What goes in my first 2 blanks? What goes in my first 2 blanks? Negative. Good. Negative 4 plus 16. Yes. Minus negative 16 plus 16. Wonderful. Plus negative 3 plus 2. Beautiful. So negative 3 minus negative 2, that becomes plus 2. Excellent. Excellent. Okay. Now, on to the next step. What is negative 4 plus 16? Same thing as 16 minus 4. 12. Good. So I've got 12 squared plus negative 3 plus 2 is negative 1 squared. Good. Still the square root of all of that. So, next step here, what is 12 squared? 144. Good. And what's negative 1 squared? 1. So, 144 plus 1 is 145. And let's find the square root of that. What's our answer? 12.02? I got 0.04. I wonder why yours is just slightly different. Square root of 145. You got the 12 right. You got 0.4 as well? Okay.
Well, now I'm getting 0.4.
Maybe you just wrote 0.2 from the last problem. That's alright, so. 12.04 units. Okay, you guys getting those? I think you are. Looking around the room, it looked like you guys had them, and nobody looks too scared, so I think that's good. Okay, guys, so what we have now is our exit ticket. Each of you should already have one at your table. You're just going to do 2 of these problems. You're finding the distance between each given set of points using the distance formula. And here are those. This is due on Friday. You're welcome to do it today. And whenever you finish it, you can bring it up to me and I can check it for you. Let me do my answer key first though, because I have not solved these yet. But yeah, that's going to be it today. So if you are done, you're free to go. That's it.